Hello, welcome for our today's science lesson. We are going to look at still looking at the global issues, and we are going to focus on the causes of climate change. Before we move on in any other aspect, it is very important and vital for us to ask ourselves, what is climate change? What is climate change? From there, we'll be able to move and look at various aspects that brings us to the understanding of the climate, and then we look at various factors that pertain into the climate system. As you know, it is also very important. We know that climate is an average change in the patterns of weather and the related changes. Climate change is the average change in weather patterns. Average change in weather patterns or patterns of weather and related changes in the ocean and related changes that may occur in the ocean. These changes may occur in the ocean, land surfaces, and ice sheet. These changes may occur on land surfaces and ice sheets over a given time scale. These changes happens over a given time scale. And this time scale may happen in various ways, because the time scale on geomorphology, when we look at the time scale, it may occur over the decades. This may occur over the decades as such changes have been observed. Can be over the decades and various area. Now, when we look at the climate change, it is the average change in the weather patterns. The average change in the weather patterns and the related changes, other related changes. These other related changes could occur in the ocean. These other related changes could occur in the ocean. It could also occur on land surfaces or perhaps in the ice sheet. And it is also worth noting that these changes, as they occur, they affect also various components of the weather system. Then we cannot be able to move unless we are also able to understand what is weather. What is weather? What is weather? Weather is the state of the atmosphere over a short period of time. We may say that weather is the state of the atmosphere the state of atmosphere that has been recorded over a short period of time, and this time could actually depict 24 hours, could also depict weeks, and so forth. Therefore, weather is the state of the atmosphere over a short period of time. We also have other understanding about weather. We can also say that, or weather is the daily, it is the daily atmospheric condition, daily atmospheric condition of a given place. This condition is of a given place that has been recorded over a short period of time. This has been recorded over a short period of time. And now, all this weather or the condition of the atmosphere, the state of the atmosphere that has been recorded over a short period of time, this period of time can depict either weeks, it can be several days, or it can also be within 24 hours. Therefore, it is worth noting that it is also the daily atmospheric condition of a given place over a given period of time. And as we know, the weather elements are observed from various weather elements. This atmospheric state or the atmospheric conditions is observed over and recorded by observing various weather elements. This is recorded and observed. All these, I will say that all these have been observed. All these have been observed and recorded from various weather elements. All these are observed and they are recorded from various weather elements. There are various weather elements that we have to observe them, record them, and analyze. Such weather elements, they include temperature, we also have humidity, we have sunshine, we also have cloud cover, we can also have wind, and perhaps rainfall or precipitation, and so many other weather elements that can be observed in various areas. When we observe these weather elements, we are able to record them over and be able to come up with a daily condition of the atmosphere. And this one is very, very much important. And now, when we observe all these weather elements. For example, temperature and maybe precipitation or rainfall. We can keep its record and its data for a long period of time. All these, when we record them over a given period of time, for example, if the time goes beyond 30 and above years, and then we can be able to come up with an average patterns of the weather elements of a given place, and then we refer to that one as the climate. For example, we can have a temperature data, and it is recorded, temperature is recorded in degrees Celsius. And remember that rainfall is also recorded. Rainfall is recorded in millimeters. We can have various months such as January, February, can have March, we can have April, we can have May, we can have the month of June, July, August, it can be September, and then we have October, November, and eventually the month of December. Now, when we have actually found out that this is for a given weather station, this data could be for a given weather station. The temperature that has been recorded in this month, in the month of January, let's say it was 24 degrees Celsius, and then the month of February it was 23, the month of March it rose up to 25, the month of April it was 25 again, and then May 24, June 24, July 22, August 21, then September it was 20, October it was 23, November 24, and December it went up to 25 degrees Celsius. And then maybe the amount of rainfall for this station, it could be 100 and that is 109 millimeters, and then 110 millimeters. This is 120 millimeters. In the month of April, it could be 135 millimeters. And then the month of May, it could be 120. And then June, it was 180, 185. Then the month of August, it was 190. And then September, it was 200, 215, 220. It has also been escalating. The month of November, because temperature has risen, also the rainfall could also be rising. And then December, it was 145 millimeters of rainfall. When we record this data in a tabular format, when we record the following data in a tabular format, we'll be able to have come up with a given statistical data for a given weather station. And this marquee, we have been able to observe a given weather element for a whole year. For a whole year, we have observed these weather elements in the month of January, the month of February, the month of March, the month of April, the month of May, the month of June. Then we have July, we have August, we have the month of September, the month of October, and then eventually the month of December. And that is where we have had, this one is temperature that has been measured, and the same the amount of rainfall. Now from this data that we have, remember it is for a given station. This station could be noted as station A because it is synonymous. It could be for a given weather station, and this weather station, the meteorologists have observed these two phenomena of weather elements such as temperature and rainfall. And in the month of January, rainfall was 109 millimeters. February, it was 110 millimeters. 120 millimeters in the month of March. 135 millimeters in the month of April, while 120 millimeters in the month of May, 180 millimeters of rainfall in the month of June, 185, that was July, 190 August, 215 millimeters and 220 in the month of October. November was 250, while December had 245 millimeters of rainfall. It goes also hand in hand with the amount of temperature. This is the daily mean temperature. The daily mean temperature is actually calculated by, if we want to get the daily mean temperature, we take, that is the highest mean, the highest temperature recorded in the day plus the lowest temperature recorded in a given day. We divide by 2, and then we get the average mean daily temperature. And then when we want to also get the monthly mean temperature, the monthly mean temperature, we'll have to get the summation of all the temperatures in a given year or of all the months. We get the sum of all the temperatures that have been recorded in the year or maybe in the month, and then we divide by the number, we divide it by the number of months of a given year. For example, it could be 12 months. If we do that one, we are getting what we call the annual mean temperature. This is the annual mean temperature. We have to calculate it that way. Therefore, look here. We have begun with the daily mean temperature. The daily mean temperature, we have to calculate, that is the highest recorded temperature and the lowest recorded temperature of a given day, so that we could get, for example, in that day, it could be several days in the month of January. Maybe it was the day of Monday. If Monday, it was the highest temperature was 22, not 22, the highest temperature was 26. And then now when we look at the highest temperature of the month of the day of Monday, it was 26, and then the lowest temperature was 22. We have to add this together, and then we divide by 2, and then we'll get 24 degrees centigrade. After getting this 24 degrees centigrade, this is the one that we are going to post it here. As we have posted it here, it becomes the average. We do it continually. Monday, the whole week. We have to do it in the whole week. As we observed, the whole weeks of the month of January. That is now all the days in the month of January. If it was all days in the month of January, then we have to add. After adding, then we get the monthly mean temperature. For example, this is 23, the month of January, and the month of February, it is 20. It becomes, that is 23, March 25, April 25, the month of May, it was 24, 24 June, July 22, August 21, September is 20, October 23, November 24, and the month of December is 25. Therefore, this is how we can do it in a weather station, can be given in your local weather station to record various elements of weather, especially temperature and the amount of rainfall. Now, after recording this, when all these weather elements have been recorded over a long period of time, for example, we record this and we keep this data for a longer period of time. This is just 1 year because it depicts that is 1 year. If we do this up to a period of around 30 years and above, and then we will come up with an average of weather elements, of weather pattern that will give us a definition of what we call climate. And then we have also to know the meaning of climate here. Before we move, we have been able to look at the various weather elements. We have looked at the various weather elements. And these weather elements, we have seen them very, very much, very important, such as temperature. Temperature is measured by a special instrument. There is an instrument that measures the temperature, and that instrument we call it thermometer. And then we have rainfall or precipitation. Rainfall is measured by an instrument known as rain gauge. And then we have wind. Wind is measured by several instruments, such as we have the wind vane that points the direction of wind. We have wind vane. We also have anemometer, the speed of wind. This one helps us to determine the speed of wind. And then we also have the windsock. This one is mostly found in the airports, and it is quite very much important. This one gives the direction of wind, while anemometer measures the velocity, that is the speed of wind. And then windsock can give us both direction and the strength of wind, the strength of the wind. We also have another instrument that is another weather elements, cloud cover, or let me say sunshine. Sunshine. When we have sunshine, sunshine is measured by an instrument known as sunshine recorder. It is referred to as Campbell stock sunshine recorder. That is Campbell stock sunshine recorder. And then we have cloud cover, because cloud is also part of the weather elements. A cloud is measured on a sensor. is actually observed on a sensor. We have just been able to look at the weather element and the instrument that help us to know and here when we look at thermometer, there are various thermometers here. We have to mention also we have the 6 thermometer, and also we have the wet and dry bulbs thermometer. Dry bulbs thermometer. Wet and dry bulb thermometer can also be used to measure the amount of temperature in a given day. Rainfall is measured by rain gauge. Wind is measured by either wind vane to determine the wind direction. Anemometer determines the speed of wind, the speed at which wind is moving. And also the windsock can also give us the direction of wind and also the strength of wind. Remember, sunshine is recorded by Campbell's stock sunshine recorder. Campbell is a scientist who invented or who discovered the measurement of sunshine by coming up with a Campbell's stock sunshine recorder. Therefore, it is named after his name. While cloud cover can just be observed in the sensor, that is in the atmosphere. Remember, we were able to look at them at various sensors in the satellites which have been placed in the atmosphere. Then let's move on and look at the climate. What is also then climate? So that we are able to understand the climate change. Climate. What is climate? It is good that we are able to notify. When you observe the weather elements and record them for over a long period of time, the analysis will bring us to what we call climate. Therefore, climate is an average. Climate is an average of weather elements, an average pattern. It's actually an average pattern. Average pattern of weather elements. These elements over a given place, of given regions, because now we are looking at various regions of the world, given region over a long period of time or over a long time scale. Can say over a long time scale or a long period of time. Now, when we look at the climate is an average pattern of weather elements of given regions or places that have been recorded over a long time scale or over a long period of time. And when the weather elements have been observed and recorded for a long period of time, and this period of time it could be between 30 years and maybe 35 years. That is the time scale we are talking about. We will come up with an average weather patterns of that region. If it is Melbourne or Adelaide, the city of Adelaide, and then we will record the weather elements in Adelaide city or Adelaide region and keep this record for over around 30 to 35 years, and then when we record them, we will also take an average of all of them. If it is 30 years, then we will also divide all those ranges on the average by, again, the number of years that we want to calculate. And then we will be able to come with what we call an average weather patterns of given regions, and that give us the climate. Now we will say that is the climate. Now, as a result of that, we are able now to understand the difference between weather and climate. But now, there are some factors that affect weather. The same factors can also be able to affect the climate. Let us look at these factors. Let us look at the factors affecting weather. Factors affecting weather. There are various factors that always influence weather in various regions, in various places. And all these factors, they play a bigger role in influencing the general climate. The same factors can also be able to affect the climate of a given area. And now when we observe a number of these factors, we will find out that one of the factors is latitude. One of the factors that affects weather is latitude. When we observe the latitude, you will realize that generally the temperature will always decrease with an increase in latitude. And that means that when you move towards the poles, there are changes that happens. Temperatures becomes lower, and this is brought about by various factors, especially one is the solar radiation that will always influence the climate. For example, I will say that generally temperature as an element of weather, temperature always increases, does not increase. The temperature decreases. Temperature decreases with an increase. Now, when we look at the temperature decreases with an increase in latitude. That means that temperature is decreasing while we are increasing in latitude. That means also that the polar regions, the temperature will become lower than the temperatures that are found along the equator or along the equatorial belt. The regions that are found along the equatorial belt, their temperatures are relatively warmer. Let me maybe make an illustration so that we are going to be able to understand by using this concept. It is very much important. These are what we refer the latitude. We have this is latitude 0 degrees. This is latitude 66 degrees, and it's always 66.5 or 66.5 degrees. And then this is north, and then this will always be south in the southern regions. And then we have another latitude here, that is the Tropic of Cancer. It could be around 23.5 degrees. This one is in the south, and then this one is 23.5 degrees in the north. Therefore, we have the main line of latitude here, which is placed at 0 degrees. And then when we just have to mention them, this is the Tropic of Cancer. The Tropic of Cancer. Remember, this one is the equator. And then remember, this one is the Tropic of Capricorn. The Tropic of Capricorn. And then this is Antarctic. We have the Arctic and the Antarctic. In the southern is the Antarctic Circle. And then in the northern part, it is actually referred to as the Arctic Circle. These are the lines of the latitudes that we have on the global Earth. And then, as we look at this area, the regions around the equatorial area, you will find that the temperatures here are relatively warmer. Why? Because when you are moving away from the equatorial region and you are going to the polar regions, temperatures decreases. The temperatures decreases. And this one will affect what we call the ocean currents, and it also affects what we call the wind system of those regions. Therefore, you will find this region having very cold and chilling effect. They are very cold. Why? Because temperatures are relatively lower. Now, it is from this concept that we understand at a given moment, why is it that temperatures decreases? The temperatures are decreasing because there are different rays that are received. The sun rays that are coming to be received, they are received at a given angle. These rays of the sun have a vital importance in increasing the amount of solar radiation. For example, along the equatorial region, this angle at which the rays fall is always at 90 degrees. And at the polar region, this angle at which the rays strikes is around 23 degrees. Therefore, this angle and this angle, you will find that the intensity of solar radiation is much more along the equatorial region than at the polar region. Number two, the distance over which the solar radiations travels to reach the Arctic Circle is longer, therefore reducing its intensity. And it will only also happen in the southern region. The same distance is the same. Therefore, the amount of solar radiation will vary because of the inclination angle over which the sun's rays strikes the earth's surface. And that gives us a very good concept of the latitude. Another factor, the second factor, is the length of the day. The length of the day. That also becomes a factor that influences the amount of solar radiation in given areas, and also generally comes to affect the temperature. For example, the periods of the solar insolation may vary. If the amount of solar radiation, let me say solar insolation, if the period is longer, and then the warmer the environment, the area becomes warmer. But if the length of the day is actually very short, and then it becomes very cold. Therefore, this one is affecting what we call the temperature. What do I mean? The longer the period, the greater the quantity of radiation that is received in a given region. But the lesser the period of radiation, actually the lesser the quantity of solar radiation that is received in that area. This is much more about the length of the day. That means when radiation takes a long time, when radiation takes longer, when radiation takes longer on the Earth's surface, will have the higher the intensity. Higher, the intensity will be higher, will have higher intensity, and that is the quantity, the quality of solar radiation that have been received in a particular area. Therefore, it becomes more important for us to understand. Let's move to the second factor. The second factor is the altitude. Altitude. Altitude generally also, altitude refers to the height above the sea level. And when we look at the height in various regions of the earth, we will find out that altitude also affects the temperature. Why? Because the temperature will always decrease with an increase in altitude. And that one happens at a given average, at a given maximum average. For example, let's demonstrate something here. We have been able to realize that temperature will always decreases with an increase also in latitude. Altitude, I mean. And altitude is just the height above the sea level. We could may be able to denote this is our sea, or maybe the ocean. This could be the sea or the ocean. And then these are various zones of altitude. When we bring the measurement of this altitude is always at the sea level is 0 degrees, that is meters above the sea level. This area could be around 1,000. This is 1,000, 2,000, 3,000. This is almost 4,000. When we highlight this one, it's actually in meters above the sea level. This is actually in meters above the sea level. You will find that the temperature that is found along this area, for example, the horizon, the zone A, and then we have zone B, and then we have zone C. Which region do you expect to have a higher temperature, relatively warm temperature. When you analyze this part, perhaps you will figure out that along this area we will have relative warm temperature. And therefore, where are you expecting very low temperatures? Very low temperatures, you expect them at point C. And as a result of that, you will now concur with this synonymous that says, the higher you go, the cooler it becomes. That means the lower the temperature. As you go high, temperatures decreases. And as you go low, temperatures increases. Why? Because the atmospheric pressure also behave in the same manner. And when the atmospheric pressure behaves in the same manner, when you rise up high or you ascend up a hill, for example, this could be a hill. You are rising up at this hill. Maybe you are climbing this hill. You will discover that the higher you go, the cooler it becomes. That means that the atmospheric pressure, that is the amount of air column that is resting on a particular point, is reducing. Therefore, we will have low pressure on top of the mountain and have high pressure in the bottom of the mountain. Therefore, low pressure brings about low temperature, while high pressure is the one that generates high temperature. Therefore, it is still the weather element or that is actually affecting the climate. Therefore, you will find that these regions along this area, this region experiences very relatively high temperatures, especially maybe somewhere along the sea level. But when you go higher the sea level, that is on high above the sea level, the temperatures will always become very low. And as a result of that, you will find that in given periods of time, then you realize that this is affected, the climate is affected. Let's move to the second aspect. The second aspect, that is just aspect. It is number 4, that is D. Then aspect. Aspect generally is the direction of the slope in relation to the sun's rays. You will discover that some regions are more exposed. Some regions are more exposed on sun rays, while others are in the sheltered regions of the sun radiation. Therefore, what will you find out? You will find out that, especially when this is the direction of the sun's rays, for example, if these are the rays from the sun just facing this area, you will find out that the whole of this slope is going to receive the high amount of solar insolation. And then in the opposite side, this region is going to be blocked out from receiving direct sun rays. And as a result of that, the area that receives a higher maximum amount of solar insolation, they become warmer. While those regions that are away from the sun's rays, they become colder, or they become very cold, relatively cold. This if it is in the same region, this also happen when we move in the north-facing slopes, because the north-facing slopes are always receiving a given amount of solar insolation. Therefore, the north-facing slopes in the northern hemisphere tends to be warmer than the south-facing slopes in the northern hemisphere, especially in the Arctic and the Antarctic regions. This is the behavior, and this behavior alters the climate. It alters the climate, actually. Then we are able to discover that as this becomes warmer, that means the temperature are relatively high, while these temperatures are relatively low. Therefore, if we compare people who are living in these regions and those who are living in this region, they have found out that this is a different climatic region zone from this, although it is in the same region. What has affected is the aspect, and that is the direction in which the slope faces. We have been able to realize that some slopes are more exposed to sunshine than others, and this affects the temperature of the region or the temperature of that given zone. As we move on to the next factor that affects weather, we have winds. Winds also becomes a factor that affects weather. It is very important, you know, wind. Wind is very important in that it is a good medium of heat transfer. Wind transfers heat from one place to another. And as a result of that, when wind carries heat to the regions where the wind is blowing, for example, it carries the wind from region A and it blows over to region B. If this region B was very cold and the wind has carried out some form of heat, this heat is going to affect the area. The areas of region B will become also warm or warmer. As a result of that, heat has been carried from point A to point B. What does it mean? This amount of heat that has been carried by the wind, it is going to affect the adjacent regions where the wind is blowing. The same may happen. For example, if these regions was very cold and the wind has carried away the same magnitude of cooling effect, that is cooling, therefore it will carry what we call the cold current. This current is going to affect, if this region was relatively warmer and then it becomes cold, causing what we call a cooling effect on the adjacent regions where they are blowing. And as a result of that, wind determines also is a factor that affects the climate of a given region. Let's look at another factor, that is the ocean. Let's look at the ocean current. Winds, whenever the winds blow over a given ocean, remember that we learned about various oceans. We have the Pacific Ocean, the Indian Ocean, Atlantic Ocean, Antarctic Ocean, and the Southern Ocean. Therefore, when the wind blows over these oceans, they adopt the temperature of the current, and actually they carry the same effect to the adjacent lands where the wind is blowing to. And this one can, if the wind was warm enough, the regions where the wind is blowing and where the ocean currents are moving, they will have what we call a warming effect onto the adjacent land, and therefore rising up the temperature of that given area. What are we saying here? When the wind blows over the ocean, it adopts, the wind adopts the temperature. The temperature of a given, that is of a given current, a given ocean current. And here we have two types of ocean currents. We have cold current, it is called ocean current, which is as a cooling effect. And then we have a warm ocean currents. The characteristic of a cold ocean current is that it is very cold, while a warm ocean current, it is very warm, therefore causing what you call cooling effect. And then this one causes what you call a warming effect in the area or in the regions where it blows. As a result of that, this become a factor that affects the weather of a given region. Then let's look also distance from the sea. We have distance from the sea. When the land, it is very important to understand that when you move away from the sea, there is a difference between the sea and the land. What happens on the land? The land normally gets heated very fast, and at the same time it loses heat faster when you compare it to the sea or the ocean. Therefore, the areas around the coastal regions are generally influenced by the ocean or the sea, because if this is the land and then this is the ocean, if this is the land, this is just a representation of the land. What happened during the day? There is solar radiation coming all over from the sun. The land will get heated very much faster compared to the ocean or the sea. Therefore, and at the same time, the land will lose its heat very fast compared to the ocean because of the terrestrial radiation. And as a result of that, if it happens the wind to blow maybe from the ocean towards the land will be affected. Why? The wind will carry some moisture. There will be warm moisture as the wind will be blowing, and as this wind blows this warm moisture is going as it moves and ascends over the land, it will cool to form some form of clouds, and eventually these regions will experience either rainfall, and this kind of rainfall that is formed is convectional rainfall because it happens either over the ocean, the sea water, or the rivers. This kind of rainfall that is formed, you'll find that convectional rainfall is going to be received. Convectional rainfall has a characteristic of it being heavy, or it is actually torrential, and it lasts for a short period of time, just to ensure that these clouds have shed off the amount of precipitation they have. When they become light, then all becomes well. And as a result of that, this becomes the factor that is influencing the climate or also the weather of given regions. We have been able to look at various factors that are affecting the weather. We have looked at the latitude, altitude, we have looked at the length of the day, the aspects, winds, distance from the sea, and at the same time the ocean currents. All these factors, when we put them together, they also affect the climate when observed for a longer period of time. Thank you. Let's meet in the next lesson.